Consider a pair of questions. How old are you? And what is your age? They mean exactly the same thing, yet they barely share a single word. So if you match them purely by their words, you fail completely, which is a disaster for search because people ask for the same thing in endless different ways. Word embeddings alone cannot rescue you here because meaning lies at the level of the whole sentence, not the individual word. Sentence embeddings solve this by squeezing an entire sentence into one vector so that similar meaning lands in a similar place. Let's unpack how. So how do we turn a whole sentence into a single meaningful vector? Follow the pipeline one stage at a time. Feed the sentence into a transformer encoder, a model like SentenceBird. It reads all the words at once, letting each one attend to the others, so it understands the sentence in context rather than as a loose pile of separate words. Crucially, that encoder was fine-tuned so that semantic similarity, not surface wording, drives where a sentence lands. Now pull those outputs. The encoder produces one vector per word, so we combine them, often by averaging, into a single fixed-length vector that stands for the entire sentence, no matter how long or short the original text happened to be. That fixed size is the whole point, because it lets any two sentences be compared with the very same math. Compare sentences by measuring the angle between their vectors, the cosine similarity. When two vectors point in nearly the same direction, they score close to 1, while unrelated sentences point elsewhere and score low. It is a single, cheap arithmetic comparison. Here is the beautiful result. Because the model was tuned so that meaning drives the geometry, close vectors mean similar meaning, even when the sentences share no words at all. Our two age questions, worded completely differently, land right next to each other. It helps to see exactly what sentence embeddings add on top of word embeddings. Word embeddings are brilliant for individual words, placing dog near puppy in a shared meaning space. But they give you nothing directly for a whole sentence. Averaging a sentence's word vectors is crude. It ignores order and washes out the very nuance that distinguishes one sentence from another. Sentence embeddings hand you one vector for the meaning of an entire sentence. Similar sentences sit close together even when they share no words, so you can measure how alike two passages are directly, with a simple distance, rather than hunting for overlapping keywords. Modern versions come from transformer models fine-tuned on pairs of sentences, so vector closeness lines up cleanly with real semantic similarity. Strip it back, and three ideas capture why sentence embeddings matter. The core idea is compression, a whole sentence squeezed into one fixed-length vector that stands for its meaning, produced by a fine-tuned transformer rather than a crude average of its word vectors. Because the model is trained on meaning, sentences that say the same thing land close together even with zero shared words, and you measure that closeness with a simple cosine similarity between the vectors. This is the backbone of semantic search and retrieval-augmented generation. You embed a query in a whole library of documents, then pull back the nearest vectors, which is exactly how modern vector databases find relevant text at scale. The same trick quietly powers clustering, deduplication, paraphrase detection, and recommendation. All right, let's lock in the essentials. Sentence embeddings encode the meaning of an entire sentence into one fixed-length vector, so similar sentences sit close together. Because meaning drives the geometry, sentences with the same intent land nearby, even when they share no words, and you compare them with cosine similarity. Modern encoders like SentenceBird are fine-tuned on pairs of similar and dissimilar sentences, so semantic closeness lines up with vector distance. They power semantic search, retrieval-augmented generation, clustering, and deduplication, though a single vector does lose detail on very long text. If watching these ideas snap into focus is satisfying, you will feel right at home with the rest of our explainers over at standarity.com. Come take a look.